Welcome to this presentation on the new innovative Piccolo F2805x series of microcontrollers. As you will see in the presentation, TI has built on the success of the Piccolo line and fine-tuned the F2805x series specifically for motor control applications. The F2805x device was designed to make developing motor control systems easier. We've increased analog integration of the device, boosted the CLA coprocessor support, and also introduced more tools and software allowing developers to bring products to market faster. The F2805X device features a CPU plus CLA processing core, control peripherals such as PWMs and ECAPs, onboard analog integration, communications, and also a security module for device protection. To make developing motor control based systems easier, TI also added a C-programmable CLA motor library, allowing software engineers to get up and running quickly. This intuitive and user-friendly building blocks allows users to hook up modular blocks of a motor control system to control all types of motors. Finally, to get up to speed with the F2805X MCU and allow design of motor control based systems around the F2805X, we offer multiple development kits, from device evaluation kits to real-world high-voltage motor development kits. These kits are complete with detailed example projects and documentation. Likewise, all software libraries, documentation, device, and kit example projects are also available on TI's free software portal called Control Suite. The new Piccolo F2805X MCUs are ideally suited for many motor control applications. A few of them to highlight are washing machine applications, textiles and sewing machines, hybrid electric vehicles, pumps, and many more applications where motor control is needed. The Piccolo F2805X MCU is a flexible motor engine. Both the CPU and CLA cores have access to motor control peripherals such as PWMs, ADCs, QEPs, caps, and comparators. This access gives developers the flexibility to perform dedicated functions on each core simultaneously. For instance, the C28X core could be used to perform speed or position sensing, communications or supervisory roles, or even checking, while the CLA coprocessor performs independent field-oriented control on a three-phase motor. With the available motor libraries for both the C28X core and the CLA coprocessor, developers have the flexibility to implement motor control loops on either the CLA or C28X core or both. The libraries offer flexible abstraction through code blocks for each motor control function. Simply connect your library blocks for the control methodology you desire, program into your F2805X MCU, and begin spinning any motor. Now, let's take a look at how the C2000 MCU has evolved over the years. Going back to the origins, C2000 started with just a CPU core, our C28X core. Users who wanted to develop a motor control system had to have external analog components such as ADCs, PWMs, etc. TI studied the needs of customers doing motor control applications and in turn developed the classic C2000 microcontroller, which includes the integration of PWMs, ADCs, communications, and connectivity, and on-chip memory. What we now had was an MCU-like device with DSP performance. Over the years, TI continued to integrate more functions on the die to enable customers to make products lower cost and smaller. The current Piccolo family of devices adds the integration of power and clocking subsystems and more analog functions such as DACs and comparators. Continuing on this vision with the Piccolo F2805x MCU series, TI further increased integration by bringing programmable op-amps and window comparators on chip. With this device, customers can decrease their system costs, reduce board size, and get to market faster. Now, let's look at the block diagram for this device. As mentioned previously, TI has added innovative new features and streamlined this Piccolo device for motor control. We start with a 60 MHz C2000 CPU and extend the system performance by adding a CLA coprocessor, also running at 60 MHz. These separate cores allow users to run parallel system configurations concurrently, such as dual motor control loops, motor control plus power factor correction, and much more. We'll revisit example applications for the CLA in later slides. The F2805X devices support up to 128 kilobytes of onboard flash and up to 20 kilobytes of RAM. This device is stacked with features such as 228-bit secure zones for code protection and even a power and clocking subsystem. Like the existing devices in the Piccolo family, this device only needs to be supplied with a single 3.3 volt input. The F2805X also has an automatic brownout reset and power on reset support to remove the burden of monitoring the voltage supply rails. Additionally, two on-chip 10 MHz oscillators with clock failure detection eliminates the need for an external clock source. Developers also get 7 PWM modules for a total of 14 PWM outputs, a 12-bit ADC with 16 channels, and also EQEPs and ECAP peripherals for motor speed, position, directional sensing, or other uses. We've added additional features specifically for motor control. 4 on-chip programmable gain amplifiers with gain settings of 3x, 6x, or 11x eliminate the need to add external PGAs or op-amps when feeding back current from a 3-phase inverter. We've also improved upon the on-chip comparators of Piccolo by adding new windowed comparators. This gives the ability to monitor for both the positive and negative overvoltage conditions. Connectivity peripherals such as UART, I2C, SPI, and CAN 2.0 are also included on this device. The F2805X will be available in an 80-pin QFP package. This device will begin sampling at the end of 2012. Now, let's take a look at some of the features that are supported on the Piccolo devices specific to motor control. While the PWM modules are available in MCUs in general, C2000 PWMs were designed specifically with motor control in mind. From the waveform creation to energy efficiency and fault protection, the C2000 PWM modules were designed for utmost flexibility. Starting with the PWM waveform creation, Piccolo devices support 16-bit shadowed timers with 3 configuration types: up count, down count, and up and down count modes. Likewise, each PWM output waveform can be formed from the time-based events, including a time-based 0, period, or 2 programmable time values. This means there are many possible combinations of PWM waveform generation types, including both symmetrical and asymmetrical waveform types, as well as many edge placement options for dual edge placement to 0 or period aligned single edge placement. The PWM modules allow flexibility in generation of control signals. Furthermore, there are built-in ADC and interrupt triggers from the PWM module, which allow streamlined control with as little latency as possible. The PWMs can directly call for an ADC conversion or CPU interrupt for fast synchronization. For energy efficiency, the PWM modules also include deadband support, which can prevent VDD to ground power losses during switching. The PWM modules also support direct trips from comparator outputs without CPU intervention. This means that the Piccolo devices can respond instantaneously to fault or trip events. This could be an instantaneous motor shutdown to prevent damage or avoid a safety hazard. Or it could mean that Piccolo could smartly recover from an unexpected system condition and stay operational. Now, let's take a look at the onboard ADCs of the Piccolo devices. The 12-bit ADC on the F2805x features 2.3 megasamples per second sampling time, allowing for high-speed feedback loops which are necessary for quick responses to system conditions. Additionally, autosequencer patterns allow designers to queue up conversions based on triggers configurable for the trigger source, channel, and sampling window size. Triggers can be set from software, CPU timer interrupts, external interrupts, or PWMs. With on-chip op-amps feeding into dual-channel sample and hold circuits of the ADC, two simultaneous motor phase readings can be measured. An input mux to the ADC is also included, allowing utilization of only 3 ADC pins for the phase readings. Finally, new to the Piccolo family are integrated op-amps and window comparators. The integrated op-amps allow current feedback for each motor phase without the need for external op-amps feeding into the on-chip ADC. The op-amps have very good performance specifications with low input offset, good gain accuracy, and a high slew rate. The windowed comparators are also new to the F2805x series. They bring the ability to monitor for both positive and negative overcurrent protection, giving motor systems more responsiveness and quicker reaction time to faults. Further, the comparators have a direct asynchronous connection which can trip the PWM modules, allowing very streamlined and responsive fault detection and correction. We've mentioned the CLA coprocessor many times so far. But what really is it, and what benefit does it have in motor control systems? In essence, the CLA coprocessor provides the performance of a dual-core device at a single-core price. CLA stands for Control Law Accelerator, and it is an independent 32-bit floating-point math coprocessor. It operates independently of the C2000 CPU with its own register set, memory bus structure, and processing unit. It also has direct access to the on-chip peripherals such as ADCs, PWMs, QEPs, caps, and comparators, and it is fully C-programmable. The CLA has low interrupt latency, allowing it to read ADC samples in real time, for reduced ADC sample to output delay, faster system response, and faster control loops. Likewise, the C2000 CPU and CLA communicate through dedicated message RAMs, allowing synchronization of control functions. By using the CLA to service time-critical control loops, the main CPU is free to perform other system tasks such as communications, diagnostics, or even another simultaneous motor control loop. Next, let's go through various use case scenarios for concurrent operation of the C2000 core and the CLA coprocessor. One example where developers can leverage the CLA coprocessor is a motor resolver. Users can perform motor position resolving algorithms on the CLA, while the main C2000 CPU runs the motor control algorithms. Most MCUs struggle with the performance needed to run motor control algorithms and would not have the extra bandwidth to also support intensive motor resolving algorithms. The CLA solves this challenge by providing a separate and independent processor to focus on just motor positioning, leaving the main CPU to focus on motor control. For those wondering about the challenge of developing your own resolver code from scratch, C2000 provides the CLA motor resolver software for free through Control Suite. Some other use cases for the CLA include running multiple motors or doing an application where a developer can control the PFC stage plus do motor control. In the dual motor control case, the CLA can control a motor independently of the C28X CPU core, while the C28X CPU core is simultaneously controlling another motor independently of the CLA. The CLA and C28X core could still communicate with each other to synchronize motor operations if needed. In the PFC plus motor control case, the CLA could be used to perform the control functions of the PFC power stage, while the C28X core performs the control functions for running a motor. Instead of using two separate controllers for the PFC and motor control, with the CLA and C28X combo, you can integrate both of these control functions into a single F2805X device. Developers can also leverage the CLA as a safety checker. With traditional single-core devices, if the CPU should fail, then the control loop is open and the system becomes unstable. There is no backup, there is no recovery. With the CLA on the F2805X, both the CLA or the C28X CPU could monitor each other to detect improper operation and gracefully recover from failed conditions. Likewise, the CLA and C28X CPU can both monitor ADC results or PWM generation for accuracy. Here we have an application example of a larger system setup where the Piccolo F2805X is serving a role as a dedicated smart node. You have a master device such as the AM335X, providing the human-machine interface and communicating to multiple motors in the system. Rather than using multiple devices to perform the various functions required of each motor node, developers can use a dedicated Piccolo F2805X MCU for each node. The F2805X with CLA can do the torque control, interface to and calculate the rotor position, and or provide advanced motor analysis and diagnostics. The CLA plus CPU combination of the F2805X could even be used for the CLA plus CPU combination of the F2805X could even be used to run redundant sensorless motor control algorithms to verify the control of a motor. TI has a free CLA motor library which makes designing motor controls as simple as connecting up blocks of a system. Simply connect up the blocks of a control system and you can automatically generate and compile your code and also flash that code onto your device. It's literally as simple as that. Motor libraries are provided for both the C28X CPU and the CLA core, making it easy to get started with motor-based development. Not only that, but the look and feel of the code blocks are the same between the CPU and the CLA. The C2000 motor control libraries are an accumulation of 15 years of experience controlling motors. C2000 is serious about spinning motors and we want to give our customers the best tools possible for making innovative designs. Lastly, TI provides an ecosystem complete with hardware and software support for the F2805X MCU. From a tools perspective, TI also introduces an isolated control card and experimenters kits for evaluation of the F2805X device. Developers can get access to all device pins as well as a breadboard area for experimentation. Designers can buy a high-voltage kit with the F2805x control card. On the software side, the CLA motor libraries and the C28X motor libraries are available to simplify development of intelligent motor systems. TI provides example projects, documentation, user guides, and much more to help developers get up to speed fast. All C2000 software is provided through C2000's Control Suite software platform. If you haven't heard about Control Suite, it is a free software portal providing all the design support you need in one place. Users can get access to software libraries, device headers, example projects, demo GUIs, application notes, and much more. Visit www.ti.com/Control Suite to download Control Suite today. To help users through the process, C2000 provides free on-demand training online. For those tough questions that need fast answers, developers can get help from TI engineers through the E2E forum on ede.ti.com. I hope you're excited about the launch of the Piccolo F2805x series of devices. With this device, designers can reduce their BOM cost, add features to their systems through the CLA, and also get their motor control applications completed quickly. Thank you for listening. We'll see you next time at the next C2000 training.